Hello and welcome. This is SETS video number 25 and today we are learning about some special tools that we need before we start solving practical problems on sets. We are going to learn about one or two very specific things that we must know before we take up solving sets problems that we face on our day-to-day lives. Now, let's quickly take a look at some of the core concepts of sets that we have already learned. We have learned how do we represent a set in the form of a Venn diagram. We have learned what is meant by union of sets. We have learned what is meant by intersection of sets. We know how to find out difference of sets, and we have learned what is meant by complement of a set. These core concepts, I'm going to provide a video URL for these in the top right side corner of this video and also in the description box below. Now we have seen what do these Venn diagrams represent. 1, 2, 3, 4, 5. So let's quickly take a look at them. So here the green color circle, or oval I should say, represent a set which is inside of a universal set. So this is a subset of the universal set. Here we see there are two sets represented by the blue color and the red color circles respectively. They both are subsets of the universal set and they are disjoint sets. They do not overlap. They don't have any common element. Here we see two sets and the pink color part represents the intersection of these two sets. Here we see a green color circle inside of a bigger circle. So the smaller circle, let's call it set A. So that is a subset of the bigger circle if it were set B. So A is a subset of B and both A and B are subsets of the universal set. And finally here we see there are four sets represented by the four circles. So we can maybe quickly give them names. So here let's call this set A, this is B, this is C, and this is D. And the rectangle is our universal set. We see that set A has no common elements with any of the sets B, C, or D. We notice that the pink color part represents B intersection C and the green part represents set C intersection D. So these are things that we have already learned. Now we are going to shift our focus to calculating number of elements inside of a set. What do we mean by that? Let's take a look. So here, we have two scenarios when we are looking at two sets. So the two sets in this case, in the first scenario, let's call the big circle set A and the small circle set B. Here set A and B are disjoint sets. That means they do not overlap, they do not have any elements in common. Whereas in the second scenario, we note that set A and B, they do overlap and they have this part which is common to both the sets. Now what we want to do is we want to find out the number of elements inside A union B. So this represents the number of elements inside the set and our set is A union B. So how are we going to solve this for the first scenario? So A union B will be what? Well, because these are disjoint sets, so A union B will simply be all elements in set A and all elements in set B. Right? So all elements in set A is shown by the green color circle plus all elements in set B is shown by the blue color circle and they do not overlap. So in this case A union B is simply all elements that belong to set A and all elements that belong to set B. Right? Now, what about the same question here? Number of elements in A union B. So here these two sets actually overlap. Now, what does this part represent? The bright green color. It represents A minus B. Let's write it over here. So this is A minus B. Right? So the number of elements in A union B, we can think of this as number of elements in A minus B, which is represented by the bright green color, Now, what does this part represent? The blue color. It represents B minus A. So here, so this part represents B minus A. So then we can think of this as, again, we are trying to find out number of elements in A union B. So it will be all the elements in set A minus B plus all elements in the set B minus A, and we have to add this part as well. And this part colored in pink is simply number of elements in the set A intersection B. So let's write it over here, plus the number of elements in A intersection B. Right? So again, our goal is to find out number of elements in set A union B. So these three are mutually disjoint sets. We have studied this before. So all elements in bright green color, all elements in the blue color, plus all elements in the pink color. If we add them, we will get A union B. Now what we are going to do is we are going to add the common part one more time, number of elements in A intersection B, but we cannot change an expression, so we have to subtract that out again. Minus number of elements in A intersection B. So you may be wondering, why did we do something like this? And this is the reason why. Now what we are going to do, we are going to take a look at A minus B. So let's highlight this here. A minus B, which is the bright green color part, and we are going to add A intersection B. If we do that, what do we get? So if we take the bright green color and add the pink color, what do we get? Well, we get the entire set A. So these two, when we add, will be simply equal to number of elements in set A. Right? Similarly, if we were to think about the number of elements in B minus A over here, and which is shown by this blue color, and if we add the number of elements in A intersection B, the pink part, what will we get? We will get simply plus number of elements in set B. And we are still left with minus the A intersection B. So let's just write it over here. So the number of elements in A union B is now number of elements in A plus number of elements in B minus number of elements in A intersection B. And this actually is a very important formula that you must remember. Especially, this is one of the two important formulas that we're learning in this video. So the number of elements in A union B will be equal to number of elements in set A plus number of elements in set B minus number of elements in A intersection B. So you may be wondering, why did we get a different answer here? We actually did not get a different answer here. What happened here in case of disjoint sets was simply, what is A intersection B here? So A intersection B is actually a null set, right? Because here these two have nothing in common. So the number of elements, so we can write it over here. So the number of elements in A intersection B in this case is simply 0. So the last term just does not appear because that value is 0. So in other words, we can say that the number of elements in A union B, where A and B can be a disjoint set or they can be a regular set with some overlapping element or elements, the number of elements in A union B will be equal to number of elements in set A plus number of element in set B minus number of elements in set A intersection B. One other way to conceptually think about that is that A union B represents all of the big circle, all of the small circle. So set A will be this entire part, right? and set B will be this entire part. So what happens here is that we calculate the common part twice when we are doing set A and when we are calculating set B. So we will have to take out the common part one time. So it doesn't get double counted. And that is why we take number of elements of A plus number of elements of B minus number of elements in A intersection B. We remove the common part one time. Now, there is a second very important formula, which is exactly an extension of this, but this time we are going to take a look at three sets. And we are not going to go into a detailed proof of that, but it is just there, so we should remember what it is. And like I mentioned before, this formula and the one we are going to take a look at next, they are very, very, very important formulas for us to solve practical problems on sets. So here is the second and final formula. So this time, number of elements in the set A union B union C. So here we have three sets, set A, set B, and set C. So the number of elements in A union B union C will be equal to number of elements in set A plus number of elements in set B plus number of elements in set C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in C intersection A plus number of elements which are common to all three sets, that is A intersection B intersection C. And like I have mentioned, these two formulas are extremely important for us to know, and they will be absolutely critical when we solve real life problems involving sets.